Hi guys, if you have questions, email me or write a comment. Hi, maybe you're asking yourself now, why do we need to find integration? Actually, let's ask ourselves this question. Let's say I want you to find the area under this curve of a function f of x. How would you find the area of such a function between a and b? Note that this is a curve, it's not straight, so how would I find the area? We don't have formulas for such things. So scientists came out with an idea of dividing this area into rectangles. But there was a small problem. If you divide into rectangles and add these areas up, you will find out that, for example, if I'm talking about the first rectangle, there will be a missing area here. If we're talking about the second rectangle, also there is a missing area. Third, same thing. So even if you want to make the rectangle with the upper limit, you will have an extra area. So how would that help me? Actually, instead of keep doing that, the idea came up with dividing it into infinitely many rectangles. If you do that with infinitely many rectangles, you will reduce the amount of area outside or lose area inside. What does that mean? This means that we are making the number of rectangles approaching infinity, and that actually gave us the integration. So integration is a limit where number of rectangles approach infinity. So the area under a curve, between a curve and the x-axis, is represented by integration. So actually, to find such an area, it's the integration of f of x, depending on x, from a to b, and that will be called the definite integral. If you remember, I told you that what we did before was indefinite integral. Now we have definite integral, and the only difference between indefinite and definite is that definite integral gives us the area, or it's bounded between two numbers a and b. Since the definite integral, the indefinite gave us capital F of x, so what does the definite means? It's the same thing, capital F of x, but from a to b, and to be able to evaluate that, we need to be able to find capital F of x first, and I'm gonna talk about what does that mean. This will always be equal to substitution of b minus the substitution of a. Now, let's keep that for a while. Let's keep that in our mind. Making use of definite integral, let's say I want you to find integration of 4 depending on x. What does that mean, and how would I find that? I'll do it in two ways. We have talked about the rule of integrating a constant. We all know that it's the constant times x. Now, what's the difference if I have it from 0 to 3, for example? What would that do? How would it affect? What does it mean? Let's evaluate it algebraically first, according to the first or the second rule that we said. Integration of any constant will be equal to the constant times x plus constant c in general from 0 to 3. How would I evaluate this? This will be 4 times 3 plus c minus 4 times 0 plus c. When you simplify this, you will get 12 plus c minus 0 plus c, so c minus c, that's only 12. Good. What does it mean? Well, how is that related to the area? Let's have a look at the function. The function here is 4. So f of x equals 4. How can we draw f of x equals 4? Let's draw the coordinates. What do we have? We have from 0 to 4, and my function is 4. Function is 4, so it's a horizontal line here passing through 4. That's f of x from 0 to 3. So I'm talking about the area between 0 and 3 of this curve, the area between the curve and the x-axis. If you look at this, this is actually a rectangle where the width is 3 and the length is 4. So the area here is immediately equal to 3 times 4, which is 12. That's the meaning of the definite integral of 4 from 0 to 3. So does it make sense? Yes, it does. That was the simple and basic example. Okay, what about integration of let's say 2x from 1 to 3 dx? Well, we don't have a rule for 2x. I didn't teach you any rule to integrate a constant times a function. We had a rule for x to the power of n alone, and we have a rule for constant alone. So till now we have no rule to evaluate this algebraically. So how am I going to deal with this? Simply just to draw it. And we know how to draw 2x. That's an easy function. So on the x-axis, the coordinates, 2x give me 0, 0, 1 and 2, 2 and 4, the function is 2x, 2 and 4, 3 and 6, you will have 0, 0 of course, so you'll have these points. It's a straight line passing through 0, 0. That's f of x equal 2x. Now, what was the question? The question was the integration from 1 to 3 of 2x, which means the area between 2x, between these two columns, 1 and 3. So I'm talking about the area here. How are we going to find this area using our area rules? Simply, you can, let's use the green color, you can divide it into this small rectangle and this triangle. So we can find the areas of these two shapes. These are regular shapes, so it's simple to find it. The length here is 2, the height is also 2. Here the height of the triangle is 4 and the base of the triangle is 2. So simply the area here will be area of a rectangle plus area of a triangle, and we all know how to evaluate these areas. So simply the area of the rectangle is 2 by 2, which is 4, plus area of a triangle, which is half times base, so half times 2, that's 1, times 4, that's 4. So in this case, the answer is 8. So the integration of this is 8 under this interval. Simply, this is the area, or this is the meaning of definite integral. Okay, let's see if you got that. What about the integration of square root of 4 minus x squared from 0 to 2, depending on x? Well, that's a little bit complicated, right? Not that much. What is this function, what does it represent? Square root of 4 minus x squared. Do you remember the circle? Supposed to. The equation of a circle is x squared plus y squared equals r squared. So in this case, what do we have? It's just like solving for y. So we have y squared equal square root of 4 minus x squared, which means the radius squared was 4, and the center in this form is 0, 0. So we have a circle with radius equals 2. So if you want to draw it, this, you will get a semicircle, radius 2, 2, 2, and so on. That's the circle. We're talking about the positive part, so this is the semicircle that we are talking about. And if it was a full circle, it would be like this. So this is our semicircle. Now, the area from 0 to 2, which means we are talking about from 0 to 2, so we're talking about this part. So actually this integration represents a quarter area of a circle with radius equals 2. So you just apply the area of a circle times 4. So in this case, this integration from 0 to 2 of square root of 4 minus x squared, depending on x, is equal to half times area of a circle, which is pi r squared. So where did I get this half from? It's 1 over 4. 1 over 4 times area of a circle, which is pi r squared. So 1 over 4 times 4, so that's only pi. So the integration is equal to pi, or in other words, the area of this quarter circle is pi only. Okay, good. So since the integration means an area, this means that... Remember to like, share, and subscribe, and write your questions via email or comments.